This is a video from Calculus 2, and this example involves work. Recall that work is force times distance. Let's take a look at this example. A cable that weighs 2 pounds per foot is used to lift 800 pounds of coal up a mine shaft 500 feet deep. The question says to find the work done. Now, before we embark on a solution, I want to go over a particular concept with you. So notice how below the question I draw out a number line. And I have 0, I have the number 50, let's say, and then I have a x that's in between 0 and 50. So it's just any number in between 0 and 50. The distance between 0 to x is x. The distance from x to 50 is equal to 50 minus x. So how did I get that? What I did was I took the distance from 0 to 50, I subtracted off the distance from 0 to x to get the distance from x up to 50. And we're going to need this idea in our solution, this type of concept. Okay, so notice how I have a picture of a cable and I have a picture of the 800 pounds of coal. Place the origin at the bottom of the cable. Okay, so the origin is here. That's where the 0 is. Divide the cable into small parts of length delta x. If x sub I star is a point in the ith interval, it is being lifted a distance of 500 minus x sub I star feet. So remember, 500 is the length of the cable, and I'm subtracting off the distance from 0 to x sub I star. And that's where I'm getting 500 minus x sub I star feet. The cable weighs 2 pounds per foot. So here's my B. So the weight of the ith part is 2 pounds per foot times delta x feet, which is 2 times delta x pounds. Okay. The work done on the ith part is 2 delta x, that's the force, times 500 minus x sub I star, that's the distance. And so that's 2 times 500 minus x sub I star times delta x. Let W sub 1 equal the work required to pull the cable. Let W sub 2 be the work required to pull the coal. So W sub 1 is equal to the integral from 0 to 500 of 2 times 500 minus x dx. So this is 2 times the quantity 500x minus 1/2 x squared evaluated from 0 to 500. And so this is 2 times 500 squared minus 1/2 times 500 squared. And when we simplify, we end up getting the following. We get W sub 1 is 250,000 foot-pounds. So where do I get the foot-pounds? So let's go back here. Remember that 2 times delta x, the unit for this force is pounds. 500 minus x sub I star, the unit for this factor is feet. And so 2 times 500 minus x sub I star delta x, the unit for this is foot-pounds. And that's where I'm getting the foot-pounds here. So W sub 1 is 250,000 foot-pounds. W sub 2, to get the work required to lift the coal, it's going to be 800 pounds, that's the force, multiplied by the distance, or I'll say the length of the cable. The length of the cable is 500 feet. So W sub 2 is 800 pounds times 500 feet, which is 400,000 foot-pounds. So the total work required, right, that's the W here, that's the total work required to lift the cable and to lift the coal is W sub 1 plus W sub 2, which ends up being 650,000 foot-pounds. Okay, that'll do it for this video. This is a video on work, and we did an example involving cable. Okay, thank you.